Okay, so here's a little bit of a tricky titration calculation to look at, and it's worth noting here that I've just taken parts of a question, but in order to answer this calculation section here, I had to look back in the question to find this value, otherwise I won't be able to answer the question at the end. So, keyword here, concordant, meaning, and it tells you in the question that the results are within 0.1 cubic centimetre of each other, and we need to calculate the mean value for this titration here, the volume of citric acid. So I'm looking across the numbers, I'm leaving out any that are not concordant, which leaves me with 3, and I'm going to add those numbers, divide by 3, and get a mean value for the volume of the citric acid. Now when I answer these questions, I make myself a table. I advise you to do the same. I'm going to have a column for my acid and a column for my alkali. I'm looking at this equation here, and the first thing to take note of is from the balanced equation that for every 1 mole of this citric acid there are 3 moles of the sodium hydroxide, which is the alkali. So the ratio of moles is 1 to 3, and that will be important later. I'm then going to divide up my table so I can fill in the information that I know about anything to do with number of moles. I don't know anything yet. The concentration of any of the substances and the volumes. So straight away we can say that there was a volume of the sodium hydroxide, which is 25 cubic centimetres, and we've just calculated the mean volume of the citric acid as 12.13 cubic centimetres. Both of these numbers now need to be changed into decimeters cubed by dividing by 1,000, which will give me 0.025 and 0.01213. So I've got my volumes in decimeters cubed. Remember that 1 decimeter cubed is 1,000 cubic centimeters, which is the same as a litre. Now in the question, it gives me the concentration of the sodium hydroxide. So that's going in my alkali section. And now I've got enough information to do some calculations. So I always think to myself, the concentration is measured in how many moles there are per unit of volume, usually a litre. So if I want to work out N, the number of moles, I need to do the concentration multiplied by the volume. I'm going to times these two numbers together and get 0.00255. Now comes the part where the ratio is important. I know that this number of moles equates to 3 in my balanced equation, so I need 1/3 of the amount of acid in terms of moles. So I'm going to divide this number here by 3 and get 0.00085 as the number of moles of acid. So this number to this number is the same as a ratio of 1 to 3. Now that I've got the number of moles of acid and I know the volume of acid, I can work out the concentration by doing number of moles divided by volume. And if I do that on my calculator, I get an answer of 0.0701. So the concentration of the citric acid is this value here, and it will be measured in moles per decimeter cubed, which is equivalent to moles per litre.